Hi, sixth graders. This is Mrs. Gall. Grab your math notebook and a pencil and put this title, Negative Exponents, at the top of your notes page for today. When you're ready, hit play. All right, let's get started with negative exponents. Before we can move on to kind of understand what's happening with negative exponents, we need to think about a few positive exponents and powers to help us through this. So 2 to the third power would be what? 8. Will you please write that down? I know you probably already know that, but we're going to look at a pattern here, so I want you to have these examples down to help you see the pattern. Now let's drop the exponent by 1, 2 to the second. What would that give us? 4. 2 to the first would give us 2. 2 to the 0 power, anything to the 0 power equals 1. What pattern are you noticing? As the exponent is dropping by 1, what's happening to our answers? Can you connect? Do you see the pattern? Maybe you saw that as our exponent decreases by 1, our answer gets cut in half. And that stays true for each one. As we take a step down, that answer gets cut in half. So what happens as we move into the side of negative exponents? Well, if we follow the same pattern, our exponent dropped by 1, which means our answer should divide in half. So if I have a 1 and I need to divide it by 2, I will end up with 1/2, or 1 over 2. Let's continue that pattern for 2 to the negative second power. Well, if I split 1/2, divide it by 2, I end up with 1/4. And if I look at one more example, 2 to the negative third, split 1/4 in half, I would end up at 1/8. As our exponent decreased by 1, our exponents cut in half. Now, when we have a whole set like this, that's easy to reason through to figure out what our answers are. But what's the way that we can actually get these answers when we're dealing with negative exponents? Let's look. So since negative exponents are repeated division, that means our value is very, very small. Not a negative, but very small. So if I had 2 to the negative third, we already found out that was 1 to the 8th. I'm sorry, 1 over 8, 1/8. But the way that we can figure that out if we don't have the pattern in front of us for all of the positives going into all of the negatives is we can place a 1 over top of the exponent in a fraction setup. And that makes the fraction, 2 to the third, a positive, as long as it's on the bottom. So 2 to the third, we would then solve to get 8. So 1 over 8 would be our answer for 2 to the negative third. Please write this down if you have not done so already. Again, this makes our value very small, but not negative. Let's practice. 4 to the negative fifth power. Start by placing a 1 over top of your exponent, which then makes your exponent positive. Next, grab your calculator to figure out 4 to the fifth power. 1024. So my answer is 1 over 1024. Y to the 0. What did we say anything to the 0 power was a few slides back? 1. And a quick way to kind of connect why that makes sense. Any number over itself, like 2 over 2, equals 1. So if I'm dealing with y's, let's say I have y to the first over y to the first, that's the same number over itself. And guess what happens when I subtract the exponents like I would since this is a division problem with the same bases? We would take the exponents there to subtract, which would give us y to the 0. And look at that, it's the same number over the same number, which also would equal 1, just like we talked through with that example. So that's kind of a little bit of a why. That's always going to give us 1. 2 to the negative first power. Well, to make that exponent positive, we place a 1 over top of it. Now we can solve for the exponent. 2 to the first power is 2, so 1/2 is our final answer. And the last one, this one has a variable involved. H to the negative 4th power. If I wanted to write that with a positive exponent, I would need to place a 1 over top of it. That makes my exponent a positive. I can't go any further because at this point I don't know the value for h, so that's the best we can do. Let's try a few where we actually have some steps to take before we can write the exponent and the final answer. So we're going to practice those multiplying and dividing tricks that we talked through in previous lessons. 2 to the 3rd times 2 to the negative 7th. What do we do with the exponents when we're multiplying bases that are the same? We add them. So 3 plus negative 7 would give us negative 4. We keep the base the same, 2. I'm not good with this because it has a negative exponent and I want to make sure my exponents are all positive and I get a final answer if I can. So let's turn this into a positive exponent by placing a 1 over top of it. Now I can actually solve 1 over 2 to the 4th by figuring out what 2 to the 4th would be. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. This would be 1/16. Let's try another one. N to the 4th divided by n to the negative 3rd. What do we do with the exponents when we're dividing bases that are the same? We subtract them. Let me write this problem out since we're going to be dealing with some negatives here. So we have n to the 4th and we're going to subtract the negative 3rd. So subtract a negative 3. What happens when we subtract a negative? Well, we want to add the opposite. So it actually turns into 4 plus 3, which is 7. That means this equals n to the positive 7th power, and I don't have to write that as a fraction because my exponent ended up being a positive. Notice how I'm combining my exponents first before I'm seeing if I need to write it as a fraction. 4 to the negative 2nd power, all to the 5th power. Power to a power means we multiply the powers. So this would be 4 to the negative times a positive gives us a negative 10th power. To make this exponent a positive, we place a 1 over top of it. 4 to the 10th drops below. Grab your calculator to tell me what 4 to the 10th would be. I'm going to grab mine. 4 to the 10th power is a very large number, 1,048,576. Couple more on here. Y to the negative 9th times y to the 4th. When we're multiplying the same base, we want to add the exponents. Y to the negative 9th plus 4. Negative 9 plus 4 would give us negative 5 for an exponent. If I need a positive exponent, I need to place a 1 over top of this. So it's 1 over y to the 5th. One more. 7, oops, if I can get that menu out of there. 7 to the negative 5th divided by 7 to the 3rd. When we're dividing bases that are the same, we can subtract our exponents. Negative 5 minus 3. Thinking about integer rules, when we're subtracting with negative numbers, we can add the opposite, which turns into plus a negative 3. That would give us 7 to the negative 8th power. I don't want a negative power, so think about how we would change that into a positive power. Hopefully you said place a 1 over top of it. Now try solving for 7 to the 8th. I'll give you a minute if you have a calculator handy. It's a very large number. 7 to the 8th, I'm getting 5,764,801. All right, you guys, something quick I want you to think about. Maybe you can write this in your notebook as a quick write. Using words, can you explain the difference between negative 3 to the 4th power and 3 to the negative 4th power? Take a second, think about it, write down some ideas. Press play when you're ready to discuss. All right, you guys, if we think about the difference here, negative 3 to the 4th power means we're taking a negative 3 and we're multiplying it by itself 4 times. It would give us a positive whole answer. The reason it's positive is we have an even number of negatives. So negative 3 to the 4th power would give us positive 81, and that's a whole answer, a whole number. 3 to the negative 4th is actually going to create a much smaller answer because we have to put this format in a fraction before we begin to make the exponent a positive. So it's going to end up being 1 over 3 to the 4th. We already found out 3 to the 4th was 81. That means 3 to the negative 4th is 1 over 81. That's all I've got for you today. Thanks for listening. Rewatch or ask questions if there's anything you need clarified.